Hi everyone, in this video we're going to cover standard ACLs. So standard ACLs are the more simplistic ACL they can use. There's only a few components to a standard ACL. One is the action. Do you want to permit or deny? That's your two choices. You either allow it or block it. Next is source IP address. That could be a network or a single IP address, which is also called a host. That is it. That is what you have to work with. Now there's two different types of standard ACLs. There is named and numbered. So a named is just like it says, use a name. So Steve's ACL. Or a number, 1 through 99 or 1300 through 1999. Now the drawback with using numbered is A, you have no idea what the number stands for. When you go through your configurations and you see a number, you don't know what it means. But B, you can't remove a rule. Let's say you have multiple rules. If you try to remove it, just one single rule, one entry, the whole ACL gets wiped out and you have to reapply it. So that's a big drawback. With named, you can remove single ACEs. ACE just stands for access control entry, so a single entry. So standard ACLs, where do you want to put them? You want to put them by the destination. Apply closest to the destination. Now, that's for about 99% of the time. Obviously, there's going to be times when you might have to put it somewhere closer to the source for the destination. Those are the exceptions, but for the most part, applying it to the closest you can to the destination is where you want to go. So let's draw out a quick little network here. So here is a very poorly drawn out network. This computer is connected here, that's connected here, and here. So we have PC1 here, PC1, we have router 1, router 2, and then of course PC2. So if we're going to apply an access control list to block PC1 from connecting to PC2, so we want to block it, where would we put the ACL? Where would we apply it? We want to apply it closest to the destination. The closest destination obviously is PC2, so we want to put it here on this interface, the closest interface to the destination network. Now, one thing I did not talk about yet is direction. When you apply an ACL, you can put it in two different directions, in or out. So you want to look at it this way. Which way is the traffic flowing? The traffic is flowing from PC1 towards PC2. So here's an interface right here. Here's an interface. And here's an interface. These are the four interfaces that we can apply it to. We want to apply it to that one, which is the closest to the destination. So it's going to go in here and out here. So we want to apply it in the outbound direction. Now you can apply it here in the inbound direction. But what happens if you have another network down here? You might inadvertently block traffic going to this network. So that's why you want to place it closest to the destination. So that way there's no chance you might accidentally block traffic to some place you don't want to block traffic. So let's see that in action now. So here's a quick little network I put together. You have PC0, 172.16.0.10, directly connected to a router. The router is 172.16.0.1, and then also on the other side, 10.0.0.1, the multi-layer switch, 10.0.0.2 on a routed port, and then of course an SVI connecting these two together. And let's just go through the configs real quick. See here, there's the IP address, very simple. the router. It's a very simple setup. Just configure the interfaces with IP addresses. Configured a default route, so that way I can easily route to other networks. And that's it. Multi-layer switch. I configured the host name just that way you know it's a layer 3 switch. Configured a username because I want to do some SSH for you. Domain name. Configured the two interfaces that are connected to the PCs as just VLAN 10. Put them all on the same network. Made gig01 a layer 3 port, a routed port. And then configured VLAN 10, also layer 2 VLAN 10, and local route. That's it. Oh, and also login local for SSH. And here's the VLAN 10 I configured. Very basic, very easy configuration. Here we go over here. Simple IP addresses, that's it. Here, simple IP addresses, that's it. Now, we can ping across the network. Come here, ping across. So I can ping across both ways. I can ping everything else. So everybody's nice and happy. Now let's configure ACLs and make sure that nobody can talk to anybody unless we tell them to. So the ACLs that we're going to configure is we are going to block PC2 from accessing PC0, but we are still going to allow PC1 through. Then secondly, we're going to configure another ACL on the multi-layer switch that's going to block PC2 from being able to SSH to it, but allow PC1 to SSH to it. So nobody likes PC2 for some reason. Let's just say that they are they're in sales. Nobody likes sales, so we don't feel bad. Alright, so let's block PC2 from accessing PC0. We want to figure out what is the closest interface. Once again, we have 3 different interfaces here, and 2 interfaces here, so 5 total. Closest to the destination, which is PC0, would be right here on router 0. So we want to apply the ACL on gig 01 in the outbound direction. So let's use a numbered ACL here. Access list, and let's just throw out any number 1 to 99. Let's just say 50. Question mark. Here you can do deny, permit, or remark. So a remark is just a comment. So remark, question mark. This is where you can put whatever kind of line you want in there, any sort of description. We don't like sales. Alright, now we have to put in the permit and deny commands. Once again, access list 50. Question mark, do you want to do permit, deny? Let's go ahead and put in a permit. So we're going to permit PC1. Question mark. Now you can do it by any, a single host, or you can put in a network. Let's just do both. We're going to do host first. Permit host. 192.168.0.10. Question mark. And that's it. Now, on the end of every ACL, extended and standard, there is a implicit deny. So what that means is that even though if you do a show run, we see these ACLs right here, invisibly right here, underneath this line right here, it says deny all. Deny any, nothing gets through. And so we could right now stop right now and the access list would work perfectly. But just so that you can see how to configure a network, we're going to configure that as well. So access list 50, we're going to deny 192.168.0.0. Then now we have to do wildcard masks. 255. So this right here is denying a whole network. This right here is permitting this one network. And now let's just say that we have, I don't know, we have multiple different networks out there, ones that aren't even configured yet. We want them to be able to access PC02. We can do this. Access list 50, permit any. Now do show run, and we'll see that we have a remark, so a description of what this ACL is supposed to do. We are permitting the PC1, then we are denying PC1's network, so PC2 cannot access it, but then we're permitting anybody else to access PC0. Now what this means right here is that the implicit deny at the very end, the one that's invisible that they can't see, will never come into play because we're permitting everything else. Now, is that good? Is that bad? Well, it's up to you because it's whatever the use case is for that ACL. Now, let's do a show command to show the ACL. So this right here is what the system sees, just like this. Now, let's just say that we did typo. We typoed something. It shouldn't be host here. It should be a host below, something different IP address, whatever it is. Let's just say no access list. In fact, let's just copy this. Copy, paste that. So now we just remove that one ACE, that one entry. And look, we lost our whole ACL. All that work we did is now gone. So that is one of the big drawbacks of using a numbered ACL. So let's just go back up here. We're going to copy this and then come back down and paste it, just because I don't like to type all that again. So now let's apply it to the closest interface to the destination, which would be gig01. So let's apply it, IP access group 50, and now the direction. We want it out. Alright, let's try pinging it. PC2. Oh, can't ping it. Dang it. Poor sales. I feel bad for them. Not really. And then PC1 can still ping away. Let's just change this to be IT. Everybody likes IT. Okay, so we just blocked PC2 from accessing PC0, but we're allowing PC1. Now let's do all that again, except this time, let's use the named ACL. So let's remove this. No. IP access group 50 out. And we can just leave the ACL in here. If this right here is not applied anywhere, it doesn't harm anything, so it can be left here. Now obviously, cleanup is a good thing. We can easily remove it, so that way it's not there cluttering up our configuration. But for right now, we'll leave it. So to do a named ACL, you want to do IP access list. And then you want to define, is it standard or extended? Standard. Now you can put the numbered in there again, so you can do 50 again if you want to, or you can actually put a name in there. So let's just put an easy name. Let's just say bad sales. Then I always like to say ACL, just so that way I know it's an ACL. And then of course the direction out. Now why do I like to put the direction in there? So that way I know which direction is being applied. And that makes it easier for me to configure things in the future and showing running configurations. And here we can put in a remark again if you want to. So we can say remark unlike sales, or we put permit, denies, whatever it is you want. If you look at this sequence number, the sequence number is the order that's going to be read in. So it starts off at 10, goes to 20, 30, 40, it skips by tens. You can add ACEs in there between 10 and 20, for example. So you can put a sequence number of 5 in there, and then I'd put it above 10, be the very first ACE. And then you can resequence everything so that way everything's by tens again, 10, 20, 30, 40. So sequence numbers allow you to insert ACEs into the ACL. So let's go through and permit again. Permit. What do you want? Same thing. It's either host, network, or any. So host 192.168.0.10. All the ACEs are just like the numbered ACLs. Same syntax. And then deny 192.168.0.0. 255, and then permit any. Now once again, you don't have to do the permit any unless you absolutely need it. And I'm just going to show you, show run. Here is the old access list. Here is the new access list. Now let's just say that we don't want this permit any in there anymore. In fact, let's just put this one ACE in there, and then we can deny the rest. Let's just see what happens. So what we can do is, let's say we were from the global configuration. We type in the command to get back in. I'm just going to copy it because I'm lazy that way. And just say no, permit any. Now, remember last time on the numbered ACLs, we did that no and it took away everything? Everything's still there and it just removed that one ACE. That is why this kind of configuration is so superior to the old-fashioned access list. So IP access list and then standard or extended and then the name. So much better. And then we just say no to this. Now, let's do this real quick. So you show access list. Let's see them both. So you see right here, all the numbers here. Let's say 5. Permit, that's 5 is our sequence number. Permit, let's just do a host that doesn't exist. Actually, let's do a network. 10.0.0.0. That is the uplink between the two routers. You can see right here, it got put in first. And then we have a deny any really invisible right here. Let me just show you what it looks like though. Deny any. If I can type, there we go. So this right here is what is invisible to you. You don't see it, but it's right here. It's at the very end of every single access list. And if you're wanting to resequence, it should just be, hopefully, packet tracer. Nope, packet tracer does not support it. But you can resequence it and put them all back in order. Alright, so let's see if it still works. Oh, I can ping it. That means something is wrong. Oh, I know what it is. I didn't apply it. Let's do that. We should probably apply it. Once again, IP access group, and then the name, and then the direction. Try it again, and it's unreachable. Try it from here, and I can. So that is numbered ACL and a named ACL. Now, they aren't really the best for controlling traffic to and from networks just because they're so simplistic. But they are good for certain things, route maps, for example, or in most cases, your VTY line access. So let's do that here. So we're going to configure a named ACL because I personally don't like numbered, and so this is how you should do it in the real world. Now I'm using a standard ACL here because we are just controlling who can access the switch via SSH. Now, how do I know just SSH when I'm not using an extended ACL? Well, I'll show you in a minute. But a standard ACL is so good for this because you're just controlling who do you want to be able to access this device. So all you need is the source. You don't need ports, you don't need destination because the local device, the router, is the destination. So standard, put in the name, just say VTY access, and then permit 192.168.0.10. Sorry, permit host. And then right now we can stop right now because you have a implicit deny any at the end. But just to make sure that we all can see it, let's just deny the host anyways, just because it feels so good to deny sales. All right, and of course we can put in a remark if we want to. Do show access list. Here it is. All right. So now let's apply it. So line V2I 0 to 15. Access class. Now we need the name. Copy and paste. Now we want to in or out. In. There we go. Now how do I know that's only going to allow SSH but not Telnet? Well, because of this command, transport input SSH. This right here should be on every single VTY line to say only use this protocol to access this VTY line. That's why. So this right here is best practice. If you do this in real life, make sure that is on all your VTY lines. All right. Show run. Here's the standard ACL. Here's the VTY line. Well, I see it went in with IPv6. Looks like I'm going to have to fix that. Now let's see. There we go. So apparently because I was putting an IP in front of it, it was thinking it was IPv6. When in reality, I wanted IPv4. So that's on me. So oops. All right. So let's go ahead and remove this. We don't want this. Do show run. There we go. All right, so now we should not be able to SSH from PC2 to to this switch, but we should be able to from PC1. So let's try from PC1 first. Just make sure it works. Username admin. Password is just Cisco. I'm in. PC2. Admin. And I'm blocked. So that's good. Now let's say that we want to add 172.16.0.10. Well, that's pretty easy. We just do this, copy paste. Now we want to put it in front of this deny host, and of course the deny any. So we want to put it in front of the deny any. So we want to make sure that's either in front of this or behind this. So we can easily just say, a sequence number of 1 through 9, because we know that'll be in front. Or we can just do this, do show IP access list. You can see that this right here are the numbers that we need. So let's just throw it in 15. Permit host 172.16.0.10. Do show access list. There it is. We do a do show run. We'll see that it's been put right in the middle. So now let's try it here. So trying to SSH from PC0 to the switch isn't working. I think I might know why. Yep. Right here we have a deny any. So we need to remove this ACL because it's basically blocking the layer 3 switch from accessing PC0. So let's say no to this. Now, how is it blocking it? It's because SSH is TCP, so it's blocking the return traffic coming back. Now let's try. And boom, there we go. So now we can see, standard ACLs are very useful, but as you saw in the very last example, they can kind of come back and bite you if you don't really pay attention to the details, like they did right here. So that is it for standard ACLs. They're very simple. You can either have an action, permit or deny. You have the source IP address. Again, that can be a host or a network. It uses wildcard masks. And you apply it closest to the destination. And in real world use, I've seen them used heavily for VTY line access, but also sometimes for route maps, if you're just looking for a network IP address and not port numbers.